Okay, Channing, I love the question that you asked me so much. I think a lot of people are going to benefit from this. You were asking me about when you graph lines and where the negative goes on the slope and how negatives affect the slope and why sometimes it feels like when you're graphing these, yours end up tilted in the wrong direction, sloped in the wrong direction. So I want to look at these four equations of lines that I have here in green, blue, orange, and pink, and put them onto the graph and see a pattern. I want to start with this green line, Channing. And I know that you've been graphing lines using equations, which is the skill we're going to do here. We see an equation. We're going to graph a line. And I'm super excited, Channing, and I hope you are too, that this equation already is in slope intercept form. Do you remember what I'm talking about when I say slope intercept form?
Where the y is by itself.
Absolutely. When this equation is solved for y, we can see two things, and mathematicians are obvious. We know exactly what two things we could see. I just said them. We call it slope intercept form because when the y is alone, we can see the slope and we can see the y-intercept. So Channing, help me look at that on the green line. What slope do you see?
So the slope is the -1/2.
Exactly. The slope is the number that's shoved up against x. So in this case, it's -1/2. And a lot of students are like, what crazy math are you doing? M equals. I'm just speaking in complete math sentences. I'm not doing math. I'm saying I know the slope is -1/2. Okay, you guys, I'm just writing in the language of math instead of writing that out in words. Okay, what else do you see in this equation?
Okay, and then you have to look for the y-intercept. So -1.
Cool. And do you remember what letter we usually use for y-intercept? Confusingly, it's not y.
B.
It is B, yeah. So I'll just speak in a complete math sentence. And that math sentence does not say do math. It says that my y-intercept is -1. I'm just making notes for myself.
The -1 is the same as -1, right?
Exactly. Yes. Oh, good. That's a little distinction we got to make sure that we know. When you see a -1 for your y-intercept, you see a number minusing. That means that you have a negative y-intercept. Ooh, good question. Okay, Channing. Now, with those two pieces of information, can you help me graph a line?
So then we always do the B first, which is our
Absolutely.
y-intercept.
Beautiful. We have to start with B because B is actually a point somewhere on the graph. Cool. Where is that point?
We need to do -1.
This -1 or this -1? What does B stand for?
The y-intercept. Oh, it has to be on the line.
Yeah, girl, it has to be on which line? That's
The
what,
y.
yeah, us mathematicians, we're really obvious. If we call it the y-intercept, it's on the y. It's where our line crosses the y. Good job. Strong work. So I'm on the y-axis, and there is where I want to graph -1. So that's a point. So I'll draw a point -1 on the y-axis. That's what it means to be y-intercept. And again, yeah, if anybody out there doesn't know, the y-axis is the one that runs vertical, the one that runs up and down. Okay, great. You helped me graph my y-intercept. Now what do I do from there?
And then now we need to do our movement.
Yes,
The
slope
M.
is a movement, not a point. Nice.
And so then we need to do -1 first, which is our rise.
So when I say rise, am I talking about a vertical movement or a horizontal movement?
You're talking about a vertical.
Good. So I'm either going up or down. A lot of students go, it's rise, it's always up. But we know that's not the truth. Rise over run is just a trick to remember which one's on the top and which one's on the bottom. Whether we're going up or down depends on whether we have a positive or negative number. So examine this fraction here, Channing. Am I going up or down?
You are going down
How'd you know?
because of the negative.
Exactly. -1 means down 1. Beautiful. So not starting at the origin, starting at our point, because M is a movement, I'm going to go down 1. So I went down 1. Beautiful.
And then now we can do our run.
Good. The denominator, the bottom number, tells me my run. And when I say run, am I talking about vertical movement or horizontal movement, Channing?
Horizontal.
Beautiful. So either left or right. What do you think?
So we need to go right in the positive 2
Absolutely.
direction.
That's a positive 2. And so we're going to go right 2. And I'm counting boxes. 1, 2. And after making those 2 movements, you can draw a point. That's where we end up after making the slope movements. Okay, I've got these 2 points down on the graph, my y-intercept, and then the point I end up with after moving my slope. And now what shall I do?
Now we have to draw the line.
Beautiful. Let me pull out my line tool here so it'll be nice and straight. And I go through those 2 points and I end up with my green line. Beautiful, Channing. Thank you. We've just graphed y is equal to -1 over 2x minus 1. I love it. Let's do the blue line next. And I promise everybody out there on the internet, we are looking for a pattern. I'm not just graphing 4 separate lines. We are going to see something really cool here. So let's go ahead, take a look at what happens when we graph the blue line. Walk me through that process, please, Channing.
We need to look at our y-intercept first, which is b.
And what's the b?
And the b is -1.
Beautiful. The number that's all by itself, not shoved up against x, is the y-intercept, -1. Nice job, Channing.
Then we have to look at our movement, which is m equals 1 over -2.
Good. Our slope, which is a movement, is 1 over -2. Gorgeous. Help me put that info on the graph.
We have to do our y-intercept first on the y line.
Good. And what is our y-intercept on the y-axis?
-1. So we need to go down to the -1.
Beautiful.
And then we need to do our movement, rise over run.
It's rise over run. Beautiful. So that means, does this top number tell me about vertical movement or horizontal movement?
Vertical movement.
Vertical, up or down. Am I going up or down?
You are going up.
Yeah, beautiful. +1 tells me to go up 1. So again, I'm starting at this point, not starting at the origin, because this is a movement. So I'm going to go up 1. So I go up 1. It has me right here. Okay, but that's not the only direction here. It doesn't just say to go up 1. It also says what, Channing?
-2. So we need to go to the left.
Beautiful. That is a run of 2. And since it's negative, left is the negative direction on the x-axis. And so I'm going to go 1, 2, and I end up right here. Okay. I got 2 points. I got my y-intercept, and then the point I got after I made the movement from my y-intercept using my slope. Now what?
And now we draw a line through the points.
Beautiful. Okay, Channing, I drew a line through those points. What do you notice about the blue line and the green line?
Blue is covering the green.
Yeah, how come? So these two are the same line. We can see we graphed the blue right over the green. And a lot of students can't see why these two are the same line. But look at these 2 equations, Channing. What's the only difference between these 2 equations?
Just the negative.
Just the negative, where the negative is in the slope. In the first equation, we had the negative up on top with the 1. In the second equation, we had the negative down on the bottom with the 2. But no matter where the negative was, when we had it up on the top or down on the bottom, we ended up getting this same line. This should make sense to us. It really should, because we know that actually one way to think about a fraction is as one of the operations. Do you remember which operation is indicated by a fraction?
Division.
Division. Channing, pick up your calculator for me. Let's do this division. Okay. So let's first do the division in the green line. And you don't have to do this to graph your lines, internet. Don't worry about it. I'm just trying to show you a pattern. So Channing, take -1 in your calculator, divide it by 2. What do you get?
You get -0.5.
-0.5. This is not my preferred way to look at slope because I can't graph a decimal, whereas it's easy to graph a fraction. But I want to see something with this. Now, I want you to take the other slope, the one on our blue line, the +1 over -2, and see what happens when you convert that to a decimal by doing the implied division. Go for it. What is 1 divided by -2?
You still get negative 0.5.
Okay, so now I've proved it mathematically by converting to decimals, and I've proved it pictorially by drawing these lines. That's the same slope. That's the same number. -1 divided by 2 is the same as 1 divided by -2. So I would say to you, Channing, it doesn't really matter if the negative is on the top or the negative is on the bottom. Whether it's -1 over 2 or 1 over -2, really what I have is a negative slope. It's the same as -1/2.
Did they get this rule from slope? Is that how they discovered it?
Oh, no, it always applies. You and I multiplied and divided with negatives the other day a lot. And what we noticed was when you just had one negative, it sticks around. I mean, we didn't use lines the other day, and we were able to discover that just by doing the division. But the thing is if we have a rule, and you and I talk about this all the time, they're not really rules, they're patterns. Mathematicians are noticing. We don't make up rules and have the numbers do that. We play with the numbers and see what happens. And we go, oh, that's the pattern. What the idea here is, if I notice a pattern one way, it better hold in all the ways. If that's how it behaves when we're dividing, it better behave like that when we have just plain old fractions. It better behave like that when we're putting on a graph. No matter the circumstance, if we're playing with -1 divided by 2 or -1 over 2, it had better behave the same way as 1 over -2, or I break math. If it behaves in different ways on a graph than it does when we're dividing, I just broke math. It needs to be something that's just true, not some arbitrary rule I make up. If we're on a graph, negatives behave like this. If we're dividing, negatives behave like this. If we're looking at fractions, they behave like that. They better be consistent across the board, or it's not math. What's true is true is true. Awesome. So we looked at the blue line and we looked at the green line, and we saw that when there was just one negative, it sticks around. We end up with a negative slope. And Channing, just looking at this graph, in case we're the kind of student who struggles with negatives, just looking at this line, can you tell me how I can tell just by looking at this line, even if I struggle with graphing, that this is a negative slope?
Because you look from the left to the right and it's going down.
Brilliant. You read a graph from left to right, just like you read a book. And if I follow this line going from left to right, it is definitely sloping downwards. It is definitely a negative slope. Woohoo! Now let's go look at the orange and pink lines. Channing, help me graph the orange line.
We have the B that you do first, which is the y-intercept, and you do -1.
Beautiful. The B is the number that's all by itself. It's not shoved up against X. -1.
And then we do the slope, which is 1 over 2.
Good. The slope is 1, +1 over 2, +2. And again, I'm not doing math. I'm just speaking in a sentence. The slope, M, is equals 1/2. Beautiful. Help me to put those two pieces of information on this graph, please.
We need to do the y-intercept first on the y line.
Good. Where do you find -1 on the y-axis?
It would be where the 0 is, it'd be the -1.
Right below 0. Beautiful.
And then we need to do the movement.
Good. Slope is a movement.
We do the rise, which is the 1. So we're rising from the point. We need to move 1.
Up or down?
We are moving up.
How'd you know it was up?
Because +1.
Beautiful. Okay. I went up 1.
Okay, so we did our up and down movement. Now we do our run. So we need to move to the right 2 times.
Good. How'd you know it was right, not left?
Because it's positive.
Exactly. +2. The positive direction is over to the right. Good. So I just moved up 1, and now I'll move right 2. And then that puts me right here. Let me put another point down after making the movement of my slope. Okay, now what?
Then connect the points together.
Beautiful. Okay, I drew a line through my 2 points. Nice. Now take a look at this line, the orange line, positive or negative slope?
looking from left to right, so it's moving up.
It is
So
moving up.
positive.
So positive slope, which makes sense because this is a positive number. 1/2 is a positive number. It had a positive slope. So no wonder I have a line that's moving up. Great. Okay, but now let's look at the pink, Channing. Help me graph the pink line this time.
So we need to do our B, our y-intercept first, which is -1. And then our movement, the slope, which is M, equals -1 over -2.
Gorgeous. The B, the y-intercept, is the number all by itself. And the M, the slope, is the number shoved up against X. Good job. Now help me to take that information, put it on this graph.
Okay, so we always do the y-intercept, which is going to be on the Y line, and you move downwards to -1.
Beautiful. So we're at -1 again.
And then we make our movement, which is our slope, and we do rise for the top.
Good. That's our up-down movement.
-1. We need to move to the negative direction, so down.
Good. Down.
We need to move 1 time.
Good. We'll move down 1 box from where we're at. Beautiful. Not down to 1, down a movement of 1 from where we're starting. And we're starting on that y-intercept. Good job.
Okay. And then we can move to our run, which is -2. So we're going to move in the negative direction 2 times.
Good. Which direction is negative when you're talking left, right?
So it would be to the left.
Good. So we'll move over 1, 2 to the left, and that puts us right here. Again, we do both movements before we draw a dot. We went down 1 and we went left 2. Beautiful. Now I got 2 dots. What now?
Now we have to connect our dots together.
Beautiful. Put a line straight through those 2 dots. And Channing, what do you notice about your orange and your pink lines?
The peak covered up the orange.
Yeah, covered it right up because it is the exact same line. So now mathematically, let's go think about that. Why would that be true? Let's look at these 2 equations and try to figure out why they would be the exact same line. Well, of course, we knew they had the same y-intercept, but look at their slopes. Their slopes at first appeared to be different. This one had a slope of +1 over +2, and this one had a slope of -1 over -2. How could they possibly be the same, Channing?
Because there's 2 negatives.
Yeah, remember, one way to think about a fraction is as an act of division. And when we're multiplying and dividing with negatives, we know that 2 negatives do what, Channing?
Cancel out.
Cancel. 1 divided by 2 is +0.5. You can put it in your calculator, guys, if you don't trust me. But guess what? If you do -1 divided by -2, the 2 negatives would cancel. Put it in your calculator again. If you don't believe me, you would still get +0.5. So once again, Channing, if division and fractions and graphs work different ways, if sometimes it was the same behavior as negatives and other times negatives behave differently in a different scenario, then I'd break math. I need, no matter if I'm looking at fractions, decimals, or graphs, these numbers to behave the same way when I multiply and divide with only 1 negative or with 2 negatives. Cool. Again, let's get to the point here. What is the point, you guys? The point is, it doesn't matter where the negatives are, on top of the fraction, on the bottom of the fraction, out front of the fraction. Doesn't matter where. That doesn't change anything. What does matter is how many. 1 negative will stick around. I'll end up with a line going down. 2 negatives will cancel. I'll end up with a line going up. Strong work. Challenging concept. A lot of students struggle with it. I think this is going to help a lot of people. Thank you, Channing.
You're welcome.
If you benefited from this video or you think your students will, please take a second to subscribe to Light and Salt Learning on YouTube, like this video, follow us on social media. We're on TikTok, we're on Facebook, I'm even on Twitter. And then I just want to thank everyone who supports me as well financially. You guys are such a blessing. You have no idea. So thanks to all my patrons for that monthly support on Patreon that is out of this world crazy cool, that you choose to support my work and support GED students across the globe. Guys, we are making a difference together. And thanks to Gracie, Amarini, Stacy, and Ashley, who headed over to buymeacoffee.com/Kate Rudman and got me coffee this month. There is nothing like a cup of coffee to keep me motivated.